Greetings, this is Brian, amateur radio call sign W9CR, and this is a little project I've been working on now for a bit here, and I apologize for the crappy cell phone video. However, I have had some damage to my current video equipment, so this is about as good as I can do, and worse, I'm going to be showing you some stuff on a monitor without doing a proper cut-in on it. But anyways, this is a little project I've been working on to do audio recording for just whatever analog input you have. In this case, I'm coming off of a CDM 1500, or CDM 750, excuse me, CDM radio. And as you can see, it's coming off of the back of the radio. There's a fixed line level output on the radio, so no matter what you have this set at, it'll work. And this is just a standard Raspberry Pi 5. I do have it in a nice case, but what I do have is a 1 terabyte hard drive in there, and that's a 1 terabyte NVMe, and that gets provisioned with the Linux Volume Manager on it, LVM, using thin partitioning. And because it's a Raspberry Pi 5, there's no SD card in here to go bad. It boots directly off of the boot partition there. And then what we have is 4 USB ports. Each one of those goes into its own sound device. And I think I have an extra one over here. These are very similar. These are the C Media sound devices. Come on, focus there. C Media sound devices. These are pretty nice. They are cheap, they're effective, and you know, what more do you need? They'll actually capture at 46 kilohertz, which is pretty cool. And you can see when they're flashing, it means they're active and they're capturing. One of the nice things is there's a guy that makes some cables. He sells them on eBay. He includes a little transformer. I'm certain I could make the same thing up, but this was, yeah, I think $20 or $30. It wasn't even a thought. So the way this is configured, each one of these has a name based on what port it's plugged into. So if you unplug them, replug them, it's going to be based on the USB port. Everything goes over Ethernet. There's no Wi-Fi or anything enabled. But further, what we've done here is we have an audio recorder. It looks for and records if there's less, does a Vox or voice activation. As soon as it hears something, it makes a file at time and date, stamps the file, and then it can further process that optionally. So with this, I've been playing around recording one of the local repeaters here for a little bit, and by default, it just records it, puts it in a directory. But I said, well, the other thing we could really do here is start using some AI functionality, and it costs a token amount of money. I think it costs under half a cent per hour or something like that. So the other thing I have set up on this is remote access service, and then also SMB, and of course for time stamping I have NTP running on there. So anyways, I'll show you some of the files that I've been getting off this. And like right here, after it post-processes it, it puts everything in what's called an OGG. It's actually an Opus Media format, but by default, it goes into a current directory. So that's the current one that's getting recorded or worked on. And that, I think, is mostly stuff from the National Weather Service I was using. But I have one keyed up here in a VLC, which can play it back. Let me hit this and go over here.
We can't get it to work. We know that you had it working on the trailer, but what do? Like, well, you gotta plug the battery in, the blue one with the black connector, and then the Renobi one has to be red on positive, black on negative. And then I heard him hauling around, and all of a sudden I heard the tractor take off.
This is time and date stamped.
Apparently they brought it in the living room and it ran into the dining room table, or the coffee table, I mean.
You can see this is during SparkNet.
Turn them off.
these are timestamped as referencing the beginning of the file. So between this and the actual timestamp of the file, you can figure out where it's at.
We all know general class can work all of 10 meters. Zero class works 60 meters and all of 10 meters. That rule out.
And this even works pretty well, as you could hear on a noisy station. So this is kind of a neat thing. What I do have running, the way I have this running actually is a, let's see, a script here. This is, whoop, that's not the script. Somewhere around here, let me find it. Here it is. So I wrote this to run from systemd. As it sees new files being made, it will work in process. So I'm, as you can see here, I'll monitor systemd, and let me kick off some new processing here. And this should give it, as you can see, it's going to first convert it to OGG format, transcribe it, upload it, and then it's going to be processed, and then it's completely done. So we go over here to, let's see, that was bottom right, 0507. Here's the text file, and I was recording the National Weather Service. This is a bit of inception here, I think.
1 foot at 4 seconds and west 1 foot at 6 seconds. Becoming northeast 1 foot at 4 seconds and west 1 foot at 6 seconds. Bay and inland waters lights off. Wednesday, southeast winds around 10 knots. Becoming southwest with gusts up to 20 knots in the afternoon. Seas around 2 feet. Wave detail.
So had this running for a while. I've probably encoded about a week's worth of repeater audio. And right now, let's see, this is my usage. Yeah, I'm at about $5.40, so it's not too much. So anyways, this is kind of a neat thing. I have some information up on my wiki on how it works. Excuse me. And, you know, if you want to build one, or I can possibly build one for you. Obviously, there's a fee and whatnot associated with that, if that's the case. But I haven't seen anything in this that you can put together that's open source that'll do this kind of out of the box. At least it's documented. There's always been the parts of it, but you know, never anything put together well like this. So, anyways, thanks for watching, and. This is Brian Fields, amateur radio call sign, W9CR, with my multi-channel Raspberry Pi based data recorder and transcriber.